Hi everyone, this is a second example that supplements Lecture 7. This example is on using arrays with loops and doing math with arrays. This is a little bit of an introduction to some linear algebra that will be related to some of the stuff we'll do later in the class. So let's go ahead and dive right in. Loops are really valuable for helping us to do things with arrays. And I hope that'll be evident in this first example. So what I'm showing here is I have this really simple array, okay, called myArray, and I use the numpyempty function to create it. So I want to say this first about this function. We haven't used it before. Empty creates an empty array, and it doesn't fill any values in it, so you don't know what you're going to get out. Okay, so if I call, I'm just showing over here in the console. If you look up in this region over here, if I call np.empty say 5, I didn't import numpy. Let me do that first. If I do np.empty, say I assign it to this array f, okay, and I print f. I don't know what's going to be in it. In this case, it happens to give me something that goes 0, 0.2, 0.5, etc. If I, make something else g, and I print g, it has something else in it. I don't know what's in there. If I want to create something I know, I can use the things we learned in our first arrays. I can use zeros or ones or something else, linspace, okay? Empty just gives me the space to put stuff in. Okay, so suppose I start out with an array that has 5, and what I'm going to do is I'm going to loop through this array. I is going to go 0, 1, 2, 3, 4, and it's going to fill the elements of each of these. So to show this, I wanted to introduce this to the empty function, but let me start with zeros here, and let me assign a value of 1 each time I go through the array. And to see this, let me do print my array at the beginning. So let me print out the array, and then every time that this fills, I'm going to have it print my array afterwards. Okay, and let's do Control Enter, let that run. Okay, so what did we get? So the very first thing that happens is I print it before, and I see I get 0. All right, and let me even okay, then the next time I should be equal to 0, because that's the first thing through. As a matter of fact, let's just add it. Let's add I right there. We'll run it again. That's pretty cheap. Okay, so this prints before. I is 0, so it goes to the 0 element and adds a 1. And then it goes down, and I start my loop again, and it goes to the element 1 right there, and it adds a 1. Then it goes to element 2, element 3, element at the index 4, adds a 1. And so you can see it's filling the array, and at the very end I can print my array. All right, so the key takeaways here is that I go through the loop, and I need to make sure that this loop loops over the values of the index that I want to do this array at. So I'm going to access the array right at that index, and I can assign it at each index what the value is. Okay, the thing on the right hand side, I can make whatever I want. So I had an I before. What that does is it goes through and puts a 0 there, puts a 1 there, a 2 there, a 3 there, and a 4 there. Okay, but I can make that I squared if I want, okay, or I can make it I times 3. Whatever I want to put in that array, I can put in the array. Now notice I don't want to put I times 2 on this side of the array, inside the square brackets. If I do that, I'm going to get an error. And look and see what happened here. So it started out with 0, and the very first I was 0, so it was okay with that. And so it put a 0 in at the 0 spot. But then when I was equal to 1, it went to 2 times I, which was the spot 2, index 2, which was my third spot, and it put a 1 there. And then the second one, it put a 2 in my spot where the index is 4. Okay, so the index is 4, and now it put there, and then it freaked out the next step because now my index was 6 because 2 times 3 is 6, and there isn't a sixth index in this array. There's only 0, 1, 2, 3, 4. So it gives me an error. It says index error. Index 6 is out of bounds. Okay, so that's out of bounds. Axis 0, that just means I have a 1D array. And it says it only has a size 5. You can't have an index 6. All right, so be careful. Remember that this is the thing you're accessing of the array, and this on the right-hand side over here is what you're assigning it to be. Okay, so just like we can fill up an array, we can fill a matrix. So now I'm making an empty matrix, and maybe again for exposition's sake, I'll make this 0 matrix. And for the moment, I'm just going to assign that to be 1. Okay, and let me print out at each stage, print my matrix. And I also print ij, my matrix. And let me print that before I ever run up here, my matrix. Okay, so we can see what it is. Now this is going to make a lot of mess. All right, so let's run it, and we'll have to scroll up a bunch. Actually, I'm going to do this. I'm going to print ij. I'm going to print this on a separate line, so it'll be a little easier to read. All right, let's do that. Let's scroll up and look at what's going on here. Okay, so now here's my beginning. Beginning matrix is a bunch of zeros. The next one, what I do is I say I'm going to go I. I has a range from 0 up 0, 1, 2, 3, 4. So it starts at 0. And then j starts at 0. And I go to my matrix 0, 0 equals 1. So I assign 1 to the 0, 0 element. Remember that the first element in an array, or in a 2D array, is the rows, and the second is the columns. So it always goes row, column. So the rows was the 0 row and the 0 column, and it went right there. Okay, so then I went around the loop now, and I'm at j equals 1. And when j equals 1, I go to the second element in the second column, but still the 0 row. So rows, columns, right there, and I assign that to be a 1. And then I proceed through all of the j's. I go j2, j3, j4, and I add a 1 marching down the columns. Okay, then this loop finishes, and I go to the outer loop and increment I now to be 1. So now I'm right here. I is 1, and then j starts at 0. So I'm on the second row, okay, the row with index 1, and the 0 element there in that column. And I work my way down the column, okay, boom, boom, 2 right there, 1, 3 right there, 1, 4 right there, okay. Now I just keep doing the same thing with I. I increment I to the next row. So I go to the next row, fill it up, fill it all the way to the end, and the next row, fill it all the way to the end. Okay, and finally I work all my way until I get down to 4, 4, which is where I've filled the whole matrix to be a bunch of 1s. Right? So now let's go back to our other example here, and we'll put in ij, I plus j, and we'll see what that does. So at the very end here, what I have is a matrix where I have different elements, but each of them is I plus j. So this is the row number plus the column number, right? So this was the 0, 0. This is 0, 1. That one is 1, 0. That's 0, 2. 2, 0. That's 1, 1. That's the sum of all those. So I get, along this band here, I get 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's filling up a matrix using a nested loop. All right. The next thing I want to show you is about some summation formulas. So if I want to do math, often I end up with summation formulas like this. It's actually easier to show you a little bit of this when I write it out. So let me get out a virtual piece of paper here, and I'm going to switch to this one right here. So this I'm going to write up here is lecture 7. Actually, I want to use this, I think. So let me do that. Lecture 7, array math. Example. Okay, so the first thing I want to show you is how to just do a sum. And then I'm going to talk about dot products a little bit. So first I'm going to do a sum, and then I'll do a dot product. And then we'll talk about some more complicated products. So we'll do that first here is 1, we'll do a sum. Okay, so suppose I have a vector v, all right? The vector v might have, let's see, what did I put in the other one? I had 1, 2, 3, 4, 5 right there. So let me do that here. I'll make it 1, 2, 3, 4, 5. Okay, and this vector, maybe you've seen, maybe in your math class they wrote vectors like this with an arrow on top. I put a line underneath my vector, all right? Or more useful for this class is I can write it in index notation and put a little I down there. So I'm going to do that instead. I'm going to call that VI. All right. Notice that that VI index notation looks a lot like if I had a vector V. I do an underscore just sort of by habit. Sorry there. And I put a bracket and I put an I. That's telling me that my index I of this array or of this vector. Okay, so suppose I want to sum up that vector. Well, I could use a summation sign and say from I equals 0 to 4 VI. What is that going to give me? That's going to give me, I just plug in the 0 for each one, or the number of the index for each one. I go V0 plus V1 plus V2 plus V3 plus V4. Okay, well, how do I do that? I have V0 as 1 plus 2 plus V2 is 3 plus V3 is 4 plus that one is 5. And what does that give us? That gives us, let's see, 9, 10, 15. Okay, gives us 15. All right, so this is summation notation. This is how I add that up. Well, how do I do that in Python? In Python, I take some value I call this sum. All right, that's going to hold my sum. And I loop through each of the values in the vector, and I say in the range of the length of the vector. So the length of the vector in this case was 5, so it's going to count 0, 1, 2, 3, 4. And I go through and I say find the vector at I and add it on to the sum. So if I come back here and look, that says I find V0, add it on, then V1, add it on, V2, add it on, V3, add it on, V4, add it on. All right, so each one as I go down, I'm adding that up. All right, so that's how I do a sum. All right, now let's think about, well, we can even check our answer, right? Let's look at how we did with the sum. Indeed, we get 15. Now let's think about how to do a dot product. So first we need to write out the formula for dot product. So here I'll do, let's see, 2 dot product. Right, let me put a line underneath that. Okay, so a dot product, if you'll recall, is something like u dot v. Okay, and that's going to be, say, u1 times v1 plus u2 v2 plus dot 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 all the way until un vn. Right, that's what that dot product means. We can rewrite that in a summation formula, just like this. I can say that's the sum over I from 0 to n, or in this case, I did 1 to n. Let me come back. Let me do this. Let me make it n minus 1. Okay, that'll make my life easier here. Minus 1. I'm going to call that one 0, just to be consistent with our code. Okay, because we start counting from 0, right? So let me be a little consistent there. Okay, so 0 to n minus 1 of ui vi. All right, so in this index notation here, I just take each of these guys and multiply them together and add them up. So that's really just a sum, but instead of having a single thing here, I now have replaced it with a product of those two things. Right? So that is going to look like ui multiplied by vi, right? Where each, I go through and loop through each index. So let's come back here and look at what I have. That's indeed exactly what I have. I have a sum. I call it dot product instead of sum. But I go through each of the elements of vector 1. And I can't do a dot product if I have two vectors that aren't the same length, so that's okay. That's going to be the same length as vector 2. And I just multiply vector 1 and vector 2 and add them up. Okay, so we can do that one. Find our dot product there is 110. Okay, and that's doing 1, 2, 3, 4, 5, with 2, 4, 6, 8, 10. Right? You can prove that to yourself if that's a problem. All right, let's go on and do a little more complicated product. Let's do a matrix vector product. So let's pull up the value here. So number 3 will be a 1, 2, 3 matrix vector product. Okay, so this will be something like A times X. So note that I put 2 lines under a matrix. This again is my the way I was trained, and then this is a vector. All right, so A will look something like say 0, 1, 1, 2. Okay, some maybe 2 by 2 matrix, and X, I'm just making this up as I go. X might look like 2, 3. Okay, and so let's remember how we go about doing this multiplication. So what I do is I take the top guy and multiply it by that guy and add it to that one times that one. So that would be A00 multiplied by, and maybe I should back up and remind ourselves, right? The elements of this matrix are A00, A01, A10, A11, multiplied by x0, x1. Okay? Again, row, then column. So row 0, column, row 0, column. So that's all row 0. And then this is column 0, column 1. That's where these 0, 0, 0, 1 comes from. Okay? Very similar to how we do it in Python, right? In Python we have, a 0, 0 and a 0, 1. Same thing right here. All right? So if I were to do this matrix multiplication, I would do, I'm going to end up with a vector at the end, right? Where I have 0 times 2 plus 1 times 3. Okay, so I do that row times that column. Then I do that row times that column, which is 1 times 2 plus 2 times 3. Okay, so remember this is going to give me 0 times 2 is 0, plus 1 times 3 is 3, and then 1 times 2 is 2, plus 2 times 3 is 6, so that gives me 8. Okay, so now if I write this out using this notation, this gives me A00 multiplied by x0 plus A01 multiplied by x1, right? This one times that one times that one. Down here I can write A10 multiplied by x0 right there, and then A11 times x1. 11 times x1. Okay, well let me generalize that a little bit to another formula. That looks a lot like the sum, right, of A0, I'm going to call it J, xj, okay, right there, right? That looks a lot like the dot product, actually, A00, x0, A01, x1, and down here it'll be another sum over j, A1, j, xj, okay? Now I have A1 down there. Well, I can write that even easier. I can just write that as the sum over j of A, I, j, xj, where I'm going to have a free index I, and that's going to give me my answer, yi. All right? And so yi is going to be this thing right here, or I could call it, up here if I wanted, I could call that y with an underscore. Okay, so that's my summation notation. So now let's translate that back to code. I'm going to do a sum over j's. So this aij should look like ai, comma j multiplied by xj, right? Because I want to multiply that one. And then this I is going to be what I'm going to assign to be my yi. All right, so let me look here, right at this one right here, and you see what I have going on. I have a double loop, okay, a nested loop, and the inner loop is over j. And what am I doing? I'm multiplying matrix 1 ij multiplied by vector j, and I'm assigning that to the product I. So what happens in this inner loop is I march down each of these different things. Now this is a 5 by 5 matrix, not a 2 by 2 matrix. So I'm going to do, multiple of these additions. So this addition will have 1, 2, 3, 4, 5 terms in it. Okay, and then another 1, 2, 3, 4, 5. And then I've got 5 rows to go down in order to get to that one. All right, so that's a matrix vector product. So run that one, and matrix vector product gives me that guy. All right, notice that that's a 5 by 1 array. Okay, so the last and most complicated thing is to do a matrix product. Okay, so let's do that one here. Let me add a new page. So we'll do 4, which is matrix vector product. All right, and in the matrix vector product, now I'm going to do something like A dotted with B. Okay, and so A dotted with B is going to give me some new vector or some new matrix C. So let me just do an example of this. Let me do A from before. Let me have A be 0, 1, 1, 2. And let me have B be 1, 2, 3, 4. That's an easy one to figure out. Okay, and let's just remind ourselves of how to do that matrix math. So I come over here, A dot B is going to equal, let's see what we do the row times the column. So we do 0 times 1 plus 1 times 3. And then I do the same row times the other column, gives me the one over here. So I have 0 times 2 plus 1 times 4. And I do this one, this row times that column, 1 times 1 plus 2 times 3. And then I do that one times this one, 1 times 2 plus 2 times 4. Okay, so that'll give me an answer. Let's see, that one doesn't even really matter for our purposes, but let's see, 3 is in that spot. 0 times 2, let's see, 4 is in that spot. I got 1 times 1 plus 6 is a 7 in that spot, and 2 plus 8 is a 10 in that spot. Okay, so all right, so that's the matrix multiplication, but what did I do here? Okay, I had little summations in each one of these. All right, so I had, if I write this out at, if I remember that A has A00, A01, A10, A11, okay, dotted with B00, B01, B10, oh man, I'm really smushing it, might as well erase now, times B11, okay, set that equal here. What do I have? I have this row times that guy, so I have A00 multiplied by B00 plus A01 multiplied by B10. And then this one I have let's see, I have that one times that one. A00 times B01 plus A01 multiplied by B11. Now down here, this one I have A10 multiplied by B01 plus see, I lost my place. A10 times B00 plus A11 times, oh come on man, A11 multiplied by B10. And then I do the last one, this one times that one. I have A10 times B01 plus A11 times B11. Okay, so now let's look at the structure of that. So hopefully you believe that this is the same as that. I just took out the numbers. So let me generalize a little bit here. So I have A0, 0. What is the same and what is the different thing here? Well, this one is always repeated on the inside, right? 0, 0. 1, 1 is always repeated. 0, 0. 1, 1. And as a matter of fact, it does 0 and then 1. 0 and then 1. Okay, so that looks like A0, J, B, J, 0. Because this has zeros on the outside, summing over J. And this one over here looks like the same thing, sum over J, but it has A0, J, B, J, 1. Because there's a 1 that's shared there. This one has a sum over J of A1J, BJ, 0. So, and then this one has the sum over J of A1J, BJ, 1. Okay, BJ1, 1, 1. Okay, well look at that. That's 0, 0, 0, 1, 1, 0, 1, 1. That looks just like 0, 0, 0, 1, 1, 0, 1, 1. I can call that guy, C0, 0, C0, 1, C1, 0, and C1, 1. All right? And so now I can say that if I write down the sum over J of A, I, J, B, J, K, I could have that be the same as C, I, K, right? Because I have the I there and the K there. And so I'm just, the repeated index is this inner index here. And this inner product or dot product, all right, is the same thing that's going on in matrix multiplication. All right, so there's my summation formula. Let's come back and look at what's going on in the code. So I'm going to loop over now 3 nested loops, an I, a J, and a K, and I'm going to have the same formula that I had here. I'm going to have CIK is going to equal, all right, so CIK or some product IK is going to equal this summation as I go over the matrix 1, IJ, times matrix 2, JK, where the J gets added up, all right? And so now I'd have I, J, K. Now K is this inner one, but it doesn't matter. It is going to add it up every time as I go through the K's, and then I do the J's, that'll add it on, and then the I's, that'll add that on, okay? And so I do that summation as I go through that loop, and I add up each of the J's to all of the different versions, all right? Okay, so that's how I do those matrix products. Let's just, and we can run that one if we want, okay? And lo and behold, we get a product out, and that's not maybe very meaningful to you. Okay, so I'm going to put away my pen for a second, and let's do a quick practice problem. So for the practice problem, I want to find the 2 norm of a vector. So a vector is defined as the square root of the sum of all the elements squared, or this right here. Okay, so I take the sum of all the elements squared, and then I take the square root of the whole thing. So let's write a loop that does that sum. Okay, so why don't you take a minute, pause the video, and see if you can figure that out. Okay, hopefully you paused it. Now you're ready to look at the answer. So let's try the answer. So I have vector 2, which I defined up there. Okay, so I'm going to need vector 2 norm, which I'm going to say is equal to 0. And then I'm going to do a for loop for I in range length of vector 2. Okay, and I'm going to go through that object. And what I want to do is I want to take vector 2 norm, and I want to add up all of the vector 2 elements squared. Okay, that'll give me the sum of all of those ones squared. Okay, but then now that I'm done with the loop, I want to take the square root of it. So I take vector 2 norm, and I want it to equal the square root of the thing I just added up. Okay, and I run that, and let me print vector2 norm. Let's see what it is. And that gives me the answer of 14.832, which is what I told you the answer would be. Great. Okay, so that's using loops to do array math. All right, using loops. Okay, so the last thing I want to show you, sorry, I gotta rub my eyes a little bit. Staring at the screen makes them water sometimes. Okay, the last thing that I want to do is show you that even though you can use loops to do a lot of things, that Numpy already has some built-in functions to make your life a little easier. So first thing is that you can do element-wise operations like multiplication or squared, okay, without having to use loops. So here I define an array called arange, all right, and I multiply it by a scalar 2. So x here is 3, the range of 3 to 21 by 3, so it goes 3, it counts up to 18, right? And I can find y will multiply by -2 by that x. And notice that when I do that, it does all of the elements, all right? So it does that really easily. And I can do the same thing down here, either by squaring the element, each element, or I can multiply it by another vector. Okay, oops. So come down here and look. If I want to find x squared, this will go element-wise and square each element. Or I can do x times y after I have y, and I can do 3 times 9 is 27, 6 times 3 is 216, etc., and do that all the way down. So element-wise operations are very easy. I can do the dot products that I just showed you before. Okay, so I showed you how to do them the hard way. Here's the easy way. Numpy defines a dot product function. So I can do np.dot, put 2 vectors in there, comma separated, and that function will give me the dot product. Okay. Similarly, I can use the dot product function to do matrix vector multiplication and matrix matrix multiplication. Again, these are just dot products. The only thing I need to do is swap the vector here for a matrix here, or swap the vector here and here for a matrix for 2 matrices. Okay, so let's look at these examples as they run. The first one, I have a simple identity matrix, which I get from the np.I function, which is kind of a tongue-in-cheek pun, right? EYE, but usually we have a capital I, but they didn't want to use the capital I. So identity matrix, which is 1s all along the diagonal, and I can multiply that using the dot product by this x, and notice that z is exactly the same as x. That's what the identity matrix should do. All right, I could do something like 2 times the identity matrix, and then I'm going to end up with double the matrix. That's just like multiplying it by a scalar by 2. The matrix matrix product, you can see C is equal to A dot B, and A is identity matrix with 3s along the diagonal, and B is a diagonal matrix with -2, so C should get -6. Of course, this works for non-diagonals, but this is an easy one to check. Okay, so there are lots of other functions that you can play with. You can look up how to create arrays. You can look up how to do other things. Maybe one more that I'd show you, because we talked about sums, is the sum function. So if I have z is np.sum of x, all right, and I run that, oh, I should print it out, print z, okay, here it adds it up to be 63. And maybe, let's see, we did this one earlier where we looked at vec1. Let's make it vec1 to show you that that one works. Okay, and it gives us 15. Okay, so I can do the sum. I can do all of these operations that I showed you that were non-trivial with loops. I can also do them with functions in Python. Okay, I think that's all I have for you, and I hope you have a great day.